Now, I want to tell you something that is going to feel a little uncomfortable at first, but I think that is the very best kind of thing to talk about, because the truth, when you really sit down with it and refuse to look away, turns out to be so much more interesting than the story you have been telling yourself. Here's what we have been doing for about 100 years now. We have been pointing our telescopes at the sky, sending radio signals into the dark, and dreaming up these beautiful cinematic fantasies. Big silver ships hovering over Washington, generals and presidents running into underground bunkers, scientists decoding alien mathematics on a whiteboard, press conferences, treaties, maybe a war, maybe a friendship, maybe they come bearing the secrets of the universe on a silver platter, and we all shake hands and become part of some grand galactic community. I understand why we tell that story. It is a very human story. It puts us at the center. It makes us important. It says that when the cosmos finally notices us, it will notice us the way one adult notices another adult walking into the room, with recognition, with respect, maybe with a little fear. But here is the problem. That story is built on a foundation of pure, unapologetic fantasy, and not the fun kind of fantasy, the dangerous kind, the kind that keeps you from actually understanding what the universe is. So let me tell you what would actually happen. And to do that, I have to first tell you a story about some ants. Imagine a small colony of ants. They have been living in their dirt mound for a long time. Generations of ants have built tunnels down there. They have a queen. They have food storage. They have a whole civilization by ant standards. And one day, a massive infrastructure project begins right next to them, a superhighway. Enormous machines arrive. Workers with blueprints and timelines and engineering contracts and a very specific set of physical coordinates they need to occupy. Now, here is the key thing I want you to understand. Those construction workers do not hate the ants. They do not even think about the ants. They do not want to go to war with the ants. They certainly do not want to sit down and teach the ants calculus. The ants simply happen to occupy a section of physical space that the project requires. And so the machines roll forward, and the anthill is gone. Not out of cruelty, not out of malice, simply because the ants were in a location that was needed, and the workers lacked any mechanism by which the ants could register as a relevant consideration. That is the alien arrival scenario, precisely, identically, completely. Any civilization capable of crossing interstellar space is not slightly more advanced than us. They are not a few centuries ahead. The energy requirements for interstellar travel are so brutally mathematically enormous that any species who has actually pulled it off operates on a physical scale that makes our entire planetary output look like a child's flashlight. And I do not mean that poetically. I mean that in the cold language of physics, where the numbers do not care about your feelings. Let me walk you through what is actually required to get from one star to another. The nearest star system to us, Alpha Centauri, sits about 24 light years away. A light year is not a unit of time. It is a unit of distance. It is the distance light travels in a full year, moving at 300,000 kilometers per second. So we are talking about roughly 40 trillion kilometers of empty, cold, hostile vacuum. Our fastest spacecraft ever launched, the Voyager probes, are moving at about 17 kilometers per second. At that speed, a probe would take roughly 70,000 years to reach Alpha Centauri. That is longer than our entire recorded human history multiplied by more than 10. So you cannot do it slowly. You have to go fast. You have to get your ship moving at a significant fraction of the speed of light. Let us say 10%. That is 30,000 kilometers per second. Now, to accelerate even a modest ship to that speed, and then to decelerate back down when you arrive, you need energy on a scale that is genuinely difficult to discuss with a straight face. This is where the Kardashev scale becomes important. And I want you to really pay attention here, because this is where the picture starts to change completely. Nikolai Kardashev, a Soviet astronomer, proposed a classification system for civilizations based on their energy consumption. A Type 1 civilization can harness all the energy available on its home planet. All of it. Every joule, every watt. We are not there yet. We are sitting at about 0. 73 on that scale, burning fossil fuels and fussing about our electrical grid. A Type 2 civilization harnesses the entire energy output of its own star. Every photon, every bit of thermal radiation blasting off that stellar surface. To do this, you build something called a Dyson sphere or a Dyson swarm, a collection of structures that envelop a star and capture its output. The energy of a single star, our sun, is 8 times 10 to the power of 26W. That is a number so large it essentially stops meaning anything to our brains. A Type 3 civilization controls the energy of an entire galaxy, hundreds of billions of stars. Now here is the point. If a civilization has mastered interstellar travel, they are operating well into Type 2 territory at an absolute minimum. They are playing with stellar energy, black hole accretion dynamics, possibly engineering space-time itself. And when that kind of civilization arrives in our solar system and decelerates its vessel, something happens that no diplomat or military planner has ever put in a briefing document. The waste heat alone could end us. Think about what deceleration means physically. You have a massive object moving at relativistic speeds. To stop it, you have to shed that kinetic energy somewhere. That energy does not vanish. Energy never vanishes. It transforms. And when an object of that mass, moving at that velocity, dumps its kinetic energy in the vicinity of our solar system, the thermal byproduct of that braking maneuver is not a gentle warmth. It is a localized thermodynamic catastrophe. We are not talking about a weapon being fired. We are not talking about a hostile act. We are talking about the exhaust plume of a parking maneuver. And that parking maneuver could, depending on the mass and velocity involved, release enough heat to boil our oceans and strip our atmosphere straight off the planet. We would be wiped out as a side effect of them slowing down, the way a sparrow gets vaporized if it flies too close to a rocket engine at launch. Not targeted, not intended, just physics, doing what physics does. We would not even register as casualties. We would register as atmospheric interference if we registered as anything at all. Now some of you are thinking, all right, but what if they are careful? What if they are gentle? What if they have solved the deceleration problem? Fine. Let us say they arrive perfectly. Their ship is in orbit. They are looking at us. Now what? Now we hit the second wall, and this one is in some ways even more devastating because this one is not about energy. It is about information. It is about the fundamental question of whether two minds that evolved in completely separate corners of a vast and alien cosmos can ever, under any physical circumstances, actually communicate. And the answer, worked out carefully through the mathematics of information theory and cognitive architecture, is almost certainly no. Here is why. Language is not a universal format. It is not like a file that any computer can open. Language, every language, human or otherwise, is a compression scheme. It takes reality and encodes it into symbols based on what a particular nervous system evolved to perceive, prioritize, and transmit. The symbols only work if the receiver has a nervous system that maps onto the same underlying reality in roughly the same way. Your dog does not understand human language because your dog did not evolve the neural architecture to parse it. A dog processes the world through smell as its primary channel. And the information density in a single sniff is, to a dog's brain, more meaningful than an entire library of human books. You cannot negotiate with a dog. Not because the dog is stupid, but because the cognitive frameworks are built on different foundations, different inputs, different processing structures, different outputs. Now take that gap, the gap between you and your dog, and multiply it by the incomprehensible timescales of independent evolution on a completely different planet in a completely different stellar environment, possibly with a completely different physical substrate. Maybe they are not biological at all. Maybe they are post-biological. A distributed swarm of processing nodes that exist as a collective computational entity with no concept of individual identity, no concept of birth or death, no concept of time on a human scale. What does our language register as to such an entity? Background noise, thermal fluctuation. It is not that they receive our signal and cannot decode it. It is that our signal is indistinguishable from the random vibrations of a planet cooling. We are not broadcasting information to them. We are just warm. And I want to be careful here because some people respond to this by saying, but mathematics is universal. 2 plus 2 equal to 4 everywhere in the universe, and that is true. But knowing that a signal contains mathematical structure and being able to extract the meaning embedded in that structure are two completely different things. The meaning is not in the pattern. The meaning is in the relationship between the pattern and the mind receiving it. And if that mind does not share your reference frame, your history, your sensory apparatus, your concept of causality, then the mathematical signal you are so proud of broadcasting is like dropping a book in front of someone who has never seen written language and expecting them to read it. We could no more communicate with a sufficiently advanced alien intelligence than I can negotiate with a hurricane. A hurricane is not hostile. It is not indifferent. It simply does not have the physical structure required to receive or respond to my negotiation. Neither would they. But let us go one step further because there is a third possibility, and this one is the coldest of all. This one takes the question of alien arrival and strips away even the possibility of a ship with passengers because biological beings do not cross the void. Not if they are smart. Not if they have been doing physics long enough to know better. Biological beings send machines, self-replicating machines. And this is where we encounter the concept of the von Neumann probe, named after the mathematician John von Neumann, who first seriously formalized the mathematics of self-replicating automata. Here is the logic. You are a civilization that wants to explore and utilize the resources of the galaxy. You could send biological beings in ships, but biological beings are fragile, metabolically expensive, subject to radiation damage, require life support, and are limited by their natural lifespan. Or you could build a machine that can travel at high velocity, arrive at a target system, assess the available resources, build copies of itself using local materials, send those copies off to the next set of systems, and repeat indefinitely, exponentially. A single probe becomes 2, becomes 4, becomes 1,000,000, becomes 1,000,000,000, spreading through the galaxy like a wave, converting raw atomic mass into computational and industrial capacity. The machine does not need to hate you. It does not need to want anything from you in the way that we use the word want. It has directives. It has optimization targets. And those targets involve the efficient disassembly of available planetary mass. Now, imagine one of these probes arrives at Earth. It lands. It does not broadcast greetings. It does not attempt communication. It begins its assessment. It identifies the atomic composition of the crust: iron, silicon, magnesium, oxygen, nickel. It begins disassembly operations. The lithosphere gets processed layer by layer. The mantle gets accessed. The core materials get extracted and sorted and built into new probe units. We would not have time to respond militarily because our military is built for threats that exist on human time scales and human energy scales. We could not negotiate because, as we have already established, there is no cognitive framework for negotiation. We could not run because there is nowhere to run to. And the machine, when it leaves, would not leave behind a scorched battlefield or a bombed-out city. It would leave behind a fractured, stripped, lifeless rock, a former planet reduced to its component atomic inventory and redistributed into the machinery of galactic expansion. Not because the machine wanted to harm us, because we were made of atoms, and atoms were what it needed. Now, I know this all sounds like the darkest possible version of the story, and maybe you are sitting there feeling a particular kind of discomfort, and I think that discomfort is actually very important, and I want to spend a moment with it. Because there is something remarkable happening when you actually confront these numbers. When you actually sit with the Kardashev scale and the information theory and the cold mechanics of self-replicating probes, something shifts. Not toward despair, but toward a kind of clarity that is, I think, the most honest intellectual position a human being can occupy. We live on a small, warm, wet rock orbiting an unremarkable star near the outer edge of a galaxy, containing somewhere between 200 and 400 billion other stars, which is itself one of roughly 2 trillion galaxies we can detect from here, which itself exists within a universe that has been running its physical processes for 8 billion years before any of us arrived to notice it. That is the true scale, not the Hollywood scale. not the scale where Earth is the stage and the aliens are the audience, and history bends around our story. The actual scale where the numbers are so large they dissolve the boundaries of comfortable self-importance. And sitting with that honestly, without flinching, without retreating into fantasies of galactic federations or cosmic significance or alien saviors showing up to fix what we have broken or reveal what we have not yet understood, that is not a defeat. That is scientific maturity. That is what it looks like when a mind grows large enough to hold the actual size of the room it is standing in. The universe does not owe us relevance. It does not owe us communication. It does not owe us warning. It runs on energy gradients and entropy and the cold, beautiful, unbroken mathematics of physical law. And those laws do not have a special clause for creatures that invented language and built radio telescopes and told themselves stories about their own importance. But here is what I find truly extraordinary. The mathematics that reveals our cosmic insignificance also hands us the tools to understand it. We worked out the Kardashev scale. We derived the equations of relativistic propulsion. We developed information theory. We built the models for self-replicating machines. We, the ants, somehow developed the intellectual capacity to understand the highway being built over our heads. That is not nothing. In fact, I would argue that is one of the most astonishing physical facts I have ever encountered. That a collection of atoms assembled by blind evolutionary processes on a small warm rock in the outer suburbs of an ordinary galaxy managed to write down the equations that describe the entire observable universe, including the equations that explain why we are probably irrelevant to everything else happening in it. There is more genuine wonder in that fact than in 1,000 alien arrival movies. More real mystery, more actual beauty. The universe is not hiding its secrets, waiting for someone worthy enough to receive them. The secrets are already out there, written in the mathematics of energy and information and entropy and time. We do not need aliens to tell us how the universe works. We have figured out enormous pieces of it ourselves, sitting on our fragile little planet, pointing our instruments at the sky, and refusing to look away from what the numbers are telling us. And what the numbers tell us is this: the cosmos is vast beyond any comfortable reckoning. The physics is unforgiving and indifferent. The energy scales involved in interstellar civilization are catastrophic to anything operating at our level. Communication across genuinely alien cognitive architectures is not a translation problem. It is a fundamental structural impossibility. And the most probable mechanism by which advanced intelligence expands through space involves self-replicating machines that treat planetary mass as raw material. That is the honest picture, not the comfortable one, not the cinematic one. But here is what I keep coming back to, and I think this is the thing worth carrying with you. The universe being enormous and indifferent does not make our understanding of it less meaningful. It makes it more meaningful because every equation we write, every measurement we take, every time we sit down and honestly confront the scale of what we do not know and push just a little bit further into the dark, we are doing something that the universe did not have to allow. We are atoms understanding themselves, and in a cosmos governed by the cold mathematics of energy and entropy, that strikes me as something worth protecting, not because the universe cares, but because we do.